Good afternoon, ladies and gentlemen, again here in Silicon Valley at, I was going to say 10th, 11th Cloud Expo. You'll see why I got the number wrong in a moment. Lunchtime Focus Keynotes. Put your hands up if you've ever attended a Lunchtime Focus Keynote at any other conference in the world. Oh, there weren't supposed to be any hands. We thought we had invented this idea, but nonetheless, there is such a thing as a free lunch, and this is the quod erat demonstrandum. The speaker coming up is going to tell a birthing story to start his presentation. I will not give away what was given birth or why, by whom or how. I will merely introduce Shannon Williams, VP of our Lunchtime Focus Keynote sponsor, Citrix Systems. Let's thank him.
Thanks, Jeremy. Oh, look at these little water bottles. Wow, thanks for having me today, Jeremy. It's great to see a good crowd. I was very nervous when I heard I was speaking over lunch, and I thought it would be big round tables and people would be chatting, and I would basically be a distraction. But it's good to see that you will have no choice but to pay attention to me as you eat your food. And not only no choice but to pay attention to me, but I don't see how you can check your iPhone, BlackBerry, Android while you eat. So this is even I now figure this must be the best speaking slot of the entire conference. So thanks everyone for showing up. As Jeremy said, this is for me, I think I've been to every Cloud Expo that has existed, that has been called Cloud Expo certainly. And I was telling Jeremy before we started that I joined Citrix last year when they acquired Cloud.com, where I was one of the founders. And at Cloud.com, we really started the company back in 2008. And at the time, we hadn't developed CloudStack. We were still just thinking about what we were going to do. And the very first quasi-Cloud Expo, was really called Server Virtualization Conference and Cloud Expo, I think, was going on at the Fairmont. And so Sheng and I went over to attend. And I had this list of people I really wanted to talk to. And I remember very explicitly wanting to sit down, and we ended up having just a number of really great meetings where we learned a lot about the space back in 2008 and when people were just kind of figuring out what cloud was. And one of them was RightScale. I was really, at the time, RightScale was really doing interesting things on top of Amazon and just starting to consider what it meant to run an application in the cloud reliably and to scale it automatically. And I felt like for the whole conference, I was stalking Torsten von Eichen, who's the CTO over at RightScale. And it's interesting because I think the conference hasn't really changed. It's still a great place for new companies to get together. Being here in the heart of Silicon Valley, it's a great place to come and learn about the big trends and to see what people are doing and to stalk vendors and learn where their roadmaps are going and what they're trying to accomplish. So my presentation today is going to focus not so much on what CloudStack is and where we've been, but it's really about what we've learned in 4 years of building clouds and some of the insights we've gained, even some pretty recently, as we've worked with lots of companies in lots of continents around the world to build all sorts of different types of computing clouds. And I think it's interesting because it all goes back to those first sessions we were making and having at the original Cloud Expo at the Fairmont, in that all of the excitement about cloud computing and everything that makes this such an interesting topic and brings so many people to the conferences and drives so many projects comes from this potential idea that cloud computing is about creating a platform that makes it very simple to run applications and to run them reliably. And the analogy that gets thrown around a lot is the utility network. It's like power or telephone, where at some point in the future, there will be computing clouds that are effectively ubiquitous, and they will be standardized, and they will be commoditized. And it will be very easy to plug your application into any of these clouds. And it's an awesome idea, but it's still pretty far away. I think 4 years ago, I didn't think it was 10 years away. 4 years ago, I probably thought it was 5 years away. And now, 4 years later, I think it's probably 10 years away as I look forward, because while there's been enormous progress and we've done a lot of things to make it easier to build clouds, and there have been millions of new apps put into the cloud and hundreds of clouds birthed since 2008, The reality is we are nowhere near a utility grid network. We are still a collection of generators that are working out there in the space. And so as I look forward, I do see real momentum coming around people wanting to consolidate and bring some commonality and some standardization and to achieve ubiquitous platforms that are available. But it's still probably 10 years away. And when I think about the goals and why this is laudable and why people get excited about this, it's a huge goal. And the potential impact is massive, because when you think about a standardized, utility-like set of clouds out there available to run almost any application, you're able to achieve real reliability for applications at a fraction of the cost of what we pay today. But if you think about it, we're not quite there. We're not able to run applications in any cloud. The clouds are very different, and the applications by and large are still not written to leverage all the capabilities that cloud computing delivers. So today, when we talk to companies, the people who are the closest to that vision are the people who have standardized and selected a cloud provider like an Amazon or a SoftLayer, and they've standardized on that. They've written their applications to run on these individual clouds, and it's largely web companies and startups and people who are developing new applications who are taking advantage of the different computing clouds. And while there are great tools like Largescale that allow you to provision to multiple clouds, the reality is they're not all running 110. Some of them are 220, some are 217, some are 105. It's the utility capability really isn't there. And yet the projects keep coming, and people keep implementing CloudStack, and they keep coming to us to do cloud projects. And I'm always interested, if they can't get that value, that they're going to drive a ton of cost out of the delivery of an application, what's driving the focus now? And what we find is that the focus now for a lot of organizations is being driven by flexibility, or it's being driven by utilization. And so people today are starting their cloud projects with a very simple goal of saying, I want to make it easier for a developer to get access to infrastructure. I want to make it easier for people to innovate. We work with a couple very large enterprises where the main goal of the cloud project wasn't to replace IT. It was to enable developers to simply start innovating quicker and enable the business to respond to new trends more quickly. So I think today, since most people haven't achieved this big vision of cutting all the costs out of delivering applications and standardizing the infrastructure, they're sort of content to focus on simplification of access and giving more people flexibility for deployment. And I think it's a laudable goal. But what I'm going to talk about today is that how I think we bridge from where we are today to where we're going in 10 years and sort of the challenges that exist in that and what we've learned. Because if you're trying to build a cloud now and you want to deploy your applications on a cloud, or you're about to start leveraging cloud computing, there is really a lot of things you need to consider in terms of the kind of cloud you want to build or the kind of partner you want to choose as your public cloud provider or private cloud provider. So what we're going to talk about is what's the right process for developing your cloud strategy, and what's the right process for actually choosing the cloud that you want to build or you want to leverage. And we're going to talk about the different building blocks and how they can be configured and set up. So this is going to be a reasonably technical conversation, and we're going to talk about the real differences that exist between different kinds of clouds and why it's not one being correct and one being wrong, but rather about selecting the right kind of cloud for the kind of applications that people are deploying. Just for a minute, I want to talk a little bit about CloudStack for people who aren't familiar with it. CloudStack is an Apache project that provides a software platform for building and deploying infrastructure as a service clouds. And CloudStack was founded by the team at cloud.com and donated to Apache by Citrix after they acquired us last year. But it is one of the most popular platforms in the world for building and implementing clouds. It powers many of the most well-known clouds in the industry, and it is used to run clouds as big as 40 or 50,000 servers. What makes it unique is that it is not only is it fully open source as part of the Apache project, but it's also very open in terms of standards. It supports many different hypervisors, different networking models, different types of storage arrays and storage solutions. So it's a very flexible platform that people use for all different kinds of purposes. Really the types of deployments range from public clouds, hosted private clouds, companies like DataPipe, KT in Korea, Ninefold in Australia, to people that are focused on more managed services and web scale deployments like Contigix here in the US or IDC Frontier in Japan, to big enterprise service provider type companies like SYS-CON or Colt or BT or Bell Canada, to the gaming sector and people like Zynga who deploy all of their games on a very large CloudStack deployment, or Spotify who runs music on it, or people like Samsung that use it to power services like Chat-On. So lots of different types of deployments in lots of different places for lots of different purposes. And because of that, we've learned a lot. We've learned a lot about different kinds of clouds for different kinds of applications and different kinds of workloads. Specifically, one of the things we found is that there is some similarity from industry to industry. In the sense, when we work with a Web 2.0 organization, they have a different perception of what cloud computing means to them than somebody like Thomson Reuters or like Autodesk or like Aetna. And so we find that people have different expectations of the cloud, they have different expectations of the users of cloud, and they really have different expectations of the kind of use cases and applications that they're going to run on the cloud. And this is very much true with service providers as well. People that are building public clouds are often building them for very different use cases and very different expectations. And probably the single biggest challenge we find is that people don't really start with a very good process for defining how they're going to build their cloud, or for that matter, their cloud strategy. And I think about it in the sense of if you look at all the clouds out there and the service providers who are offering cloud computing, there's very few of them who started with an application in mind when they started building. And I think Amazon's a good example of the inverse of this, in the sense, what makes Amazon so successful for people that are deploying on it? The best thing about it is it was built from the ground up to run one of the world's biggest applications, Amazon.com. And so from the beginning, what Amazon said back in 2006 was, here, come use the infrastructure. Here's how we run our application. And here's a reference architecture for how you can run your application on infrastructure that's the same as what we use. And it's a very interesting thing, because instead of starting with a question of, what kind of network should I use, or what kind of storage is right, or how should I develop, which hypervisor should I pick as the right one for my cloud, or which orchestration platform, they basically started with the application, built a great system to run that application, and then opened that up and said to other people, hey, if your application is like ours, this system might work really well for you as well. And it's unique. Most people didn't start with that. If you think about it, most of the service providers that build clouds started from being service providers already. They started from hosting applications and websites, and so they didn't start with a single reference architecture. They started with lots of different types of applications that had to run on that platform, and that's challenging. And so what we found is the people who have succeeded and who have built clouds that they're really happy with, and they've built them and they've scaled and they've grown, have started by at first defining the types and the target workloads they're going to run, and specifically defining exact individual applications that they're going to put on this new cloud, and why, and what's the purpose of it. And once they do that and they say, okay, we're going to focus this cloud on running our legacy enterprise applications, or on our web services, or on the developers, or different types of applications, they're able to then define how that gets done reliably. Because this is the big thing. I mean, the reason Amazon gives you a reference architecture and tells you, here's how to write your application and run your application on our system, is because they're defining for you where the limitations are and how to architect around these limitations. And the goal of that is delivering a service very reliably that can handle failing infrastructure, failing data centers, failing network connections. And too often we don't focus on that at the beginning. We focus on that later. We build something and then come in and add DR to it or add resiliency. But in building a cloud, that's absolutely the wrong approach. You build a cloud by starting with the workload, defining how that workload, what that workload needs from its systems, its infrastructure, to be done reliably. And then you define functionality. Then you start to say what your performance requirements are. Then you start to say, well, my application really needs a very good connection between the database and the app server. So I need to make sure that's always very persistent and very reliable and can handle lots of failure. Or my application needs to be distributed across data centers. But the expectation comes from the application, which drives the requirements, which then drives the actual functionality that the cloud needs to deliver in terms of HA and performance. And that eventually will help you pick the right kind of hardware, the right kind of hypervisor, the right kind of orchestration, the tools that will be necessary to orchestrate all this and turn it into a platform that can actually run these different applications. And so if you go through this process and end up implementing and deploying a cloud, you'll come out with, at the very worst case, a cloud that runs your application you started with very well and is optimized for that. And there are so many different kinds of applications that people are putting on clouds right now that you can start almost anywhere in your organization, whether it's traditional enterprise applications that are really mission critical and absolutely critical to the success of your business, or it's desktops and VDI, or it's development environments, or it's your web and mobile apps. I mean, there's lots of different types of applications that people are leveraging the cloud for. And the more time we've spent and the more we've looked at these different workloads and we've solved against that as the outcome for customers, what we found is that they're all legitimate. They can all be run very reliably in the cloud, but they do have very different expectations and characteristics, and that you need to sort of bucket them into types and categories in order to run them reliably. So what we've tried to do, and it's not absolute, but what we've tried to do is to bucket these different types of infrastructure applications into different categories that we look at and judge by their capabilities. The first being, most applications that most organizations run today, we would call sort of a traditional application or a traditional workload. It's a workload that expects very reliable infrastructure, very reliable hardware. It's probably bought from an ISV, maybe a Java application you've developed. It's Exchange or SAP, or it's your supply chain application or your point of sale application. It's a traditional application that relies on a database, and it needs really good resiliency of the entire application stack in order to be reliable. It's the kind of applications that we've spent 15 years and enormous amounts of ITIL processes on making resilient and reliable. It's things we do the synchronous replication of our SANs for. It's the big important applications that don't handle any failure well, and everything in terms of resiliency is the responsibility of the IT organization. So the business buys the application or the developer develops the application, and then they work with the IT organization to determine how to make it reliable. And this is a very sharp contrast with what we would call sort of a distributed workload or distributed application. An application where the developer is responsible for the reliability of that application, where the developer writes the application from the beginning expecting that the infrastructure might not be reliable, that a server might go down, that a network might get disconnected, that a data center might go down, and that the application will own its own reliability. And when you start to think about these, it becomes very obvious where different types of apps fit. Those traditional enterprise applications really fit in your traditional workload bucket, and your next generation Facebook mobile apps that are running on sharded databases and running on CouchDB and are running across multiple data centers. These are sort of fitting over in the distributed workload. And why this is important is because both of these styles and both of these types of applications are very legitimate. They're both real. They both occupy the IT organization of most companies. And the lion's share today would sit on the left side of the screen in the traditional workload bucket. This is what most people's data centers are full of. And these applications are hard to move to in Amazon. They're hard to move to a platform that doesn't offer a ton of resiliency throughout the cycle. And they're also, they also have the characteristic of being relatively expensive to make reliable. Whereas the distributed app workloads are pretty rare in most organizations. Most people don't have a lot of these, but they are incredibly reliable when written correctly, and they're incredibly inexpensive to operate when deployed at scale. And so they have a lot of compelling reasons that they make sense for many organizations to deploy. And so what we're seeing is if we build this big cloud infrastructure, we have to have applications that can plug into it. And that means that we have to build clouds that can consume both of these kinds of workloads. We have to build our cloud strategy considering that both of these are going to exist for a long time, and that there may be a shift coming, and that we're going to have a lot of traditional workloads maybe get replaced by their next version that's more distributed and less expensive to operate. There's going to be, for the foreseeable future, we're going to be running a lot of these legacy applications that need very good connectivity to a SQL database. And so as we think about these two different kinds of workloads, we really understand that they're going to drive very different feature requirements in the clouds we build, and that it'd be very difficult to actually build a cloud that met all the requirements of both of these. That if I was building a cloud and I was optimizing it to run Exchange or SAP, or optimizing it to run something like Oracle, I would want to really leverage all of the things we've learned from the virtualization space in the last 10 years. Things like how to do storage multipathing, and how to do link aggregation, and how to do VMHA, and how to do fault tolerance, and how to really leverage all of the capabilities that are in something like like ESX and in the hypervisor to try and make the connections and the servers and the all of that infrastructure as reliable as possible. Whereas if I'm building a cloud that's focused on running distributed workloads and running things like Facebook games and web apps and trading floor applications that are distributed, I need different types of tools and functionality. I need things like backups and snapshots and ephemeral resources. I need concepts like Netflix's Chaos Monkey, where I run programs to simulate failure throughout the application stream. I need to consider multi-site redundancy as a core component. I need an object store. I need different components that are critical to running that kind of application well. And it drives a real challenge, because while all of these clouds start with the same building blocks, every one of the 100 we've built have had server, storage, network, and hypervisor, the big difference is how the specific models and the specific types of technology you choose at each of these layers, but even more so how you architect them, how you design the network architecture, how you design the storage architecture, how you implement it. And historically, when we've built a cloud, organizations have built clouds that were monolithic. Effectively, if you go to Amazon and EC2, you would look and see that the cloud is the same whether I'm working with Japan or Singapore or Ireland or here in the Western US. I'm effectively getting a cloud made up of multiple availability zones of infrastructure that all behave the same way. And what we're starting to see is this concept of availability zones is really powerful. I mean, we've used it really today only to describe physical locations. We've said an availability zone is a place and a resource pool in a given place. But a trend that I think is really accelerating is that the concept of availability zones is going to attach more and more characteristics and more types of metadata to it besides just location. It will soon describe maybe resiliency, or maybe it will describe the type of infrastructure it's designed for, or the type of characteristics. And you can envision clouds made up of availability zones of different types designed for different workloads. And I think that is an enormous change that's starting to come, that we're going to have to find a way to start describing and delineating between the different clouds that we leverage to run our applications. And even within the same cloud, we're seeing customers build clouds with different availability zones architected to run different kinds of applications, leveraging different hardware. In fact, if you drill into one of these availability zones or a couple of these availability zones, what you find is that if you were going to build an availability zone and your focus was on building it to run the 85% of applications in the enterprise today that are traditional legacy apps that talk to a database, the first thing you would pick is you would choose to use the same virtualization technology that most people are already using to run that. You pick on, you'd choose a very intelligent hypervisor like VMware or like XenServer that do a lot of the fault tolerance and the storage vMotion and the HA capabilities. You want all that resiliency that's been built into the hypervisor, because that resiliency is very good at making those applications, keeping those applications that require a lot of state available. You'd want to use server clusters, probably blade servers, and then you'd attach a really good SAN to that cluster, because that is how you're going to do DR. It's how you're going to do resiliency of the application. It's the way you're going to deliver exceptional performance to the database. And you'll probably deploy using the same network technology that we've been using in the data center for some time. VLANs, physical firewalls, physical load balancers or virtual load balancers. And in the end, what you're deploying is something that looks a lot like a vCenter deployment today. You might even leverage multi-tier VLANs and OVF to define the application. And that's absolutely acceptable. It's absolutely acceptable and absolutely the right way to build a cloud if your goal is to run Exchange or to run SAP or to run some supply chain or point of sale application that really needs great connectivity to an Oracle or SQL database. And the upside of this is that even with just one of these zones, you can get a lot of resiliency. You don't have to run 10 of them. You can run just one of them, and most applications you can deliver 4 nines resiliency on in just this one zone. It's, you're probably going to replicate the whole thing somewhere else, the whole SAN to another location, because everything you're running here is important and you want to make sure you can recover any of it. And so you can run a platform that's very easy to import and onboard workloads that already exist in your environment. The only really big downside to this type of architecture is it's very expensive. And this is not going to save you a lot of money. You're not going to be able to cut the cost of running these applications by 50% or 60% like you might be able to with some of the other architectures. And so what we find is that this style of zone is actually really popular with our customers, that many of them deploy multiple zones that look like this. It's because these are the applications they have. This is what 85% of what runs in a data center today looks like. And so they want to optimize their cloud to run those applications. At the same time, almost uniformly, customers are thinking and considering what the future architectures look like and how they can benefit from the movement towards distributed applications that are less expensive to run and can run on much less expensive infrastructure. So if you were going to design a zone that was more Amazon-like, that was more distributed, you would take a very different architectural approach. What you would build, first thing, we'd build with pizza boxes. You'd build with standard server racks with actually lots of local disk on them, maybe 4 or 6 local disks, because you're going to want to do a lot of caching. All of a sudden, state's not as important. You're not going to be buying that big EMC SAN. So to get the IOPS performances and things like that you need from the environment, you're going to leverage commodity servers, but with lots of local disk. Again, you're not going to want to do clustering here. You're not going to want a really intelligent hypervisor trying to turn on HA and trying to do things like fault tolerance or motioning things around. You want a simple hypervisor that's reliable like Xen or KVM. So you're going to choose different architecture, different types of servers, different hypervisor. From a storage perspective, you're not going to run this with a big SAN on the back end. You'll use something like Amazon's EBS platform, something that leverages less expensive storage that is persistent. So it's more persistent than the disks that sit on those server racks, but it's not backed up. It's not providing exceptional IOPS. It's persistent storage that can be backed up later to an object store. And this could be NetApp. It could be something like Nexenta. Those are really popular choices for customers, but it's persistent. It's some kind of NFS-style storage or iSCSI-style storage. On top of it then, at the networking level, you're going to take very different choices. So instead of now deploying VLANs and physical firewalls and load balancers, all of a sudden people are going to be doing SDN. They're going to be using flat networks and direct IP addresses and things like EIP or elastic IP addresses, elastic load balancing concepts, so that the applications can be distributed more widely, IPs can be maintained, and even in a big multi-tenant environment, you can get the advanced networking capabilities like load balancing and firewalls and security groups that you need for your application, but doing it without having to buy a whole bunch of expensive NetScalers and F5s and firewalls and things like that. So you see a very different architecture, different application definition, and one last thing that's very important for this is an object store. That to do this resiliently, this whole infrastructure is based on commodity hardware that's actually not very reliable and is expected to fail. And so the developers are told that up front, said, hey, this infrastructure is great, it'll run your application, but don't count on any one VM being available or even that storage array being available. And so to do it reliably, this type of infrastructure needs some bedrock that actually is resilient and is deployable. And that's the object store. And the object store is where I can give the developer some very high SLA, 5 nines, 7 nines, 9 nines, confidence that when I write the application and back up my data, that data will be persistent even if everything else in my application is lost. So typically, when people deploy this style of cloud, they run not one availability zone, but multiple availability zones, all of which are connected to an object storage platform that allows backup and snapshot and automatically distributes data between these. And there's great technology out there to do this today. There's tools from companies like Cloudian and Coringo and Basho and others who are building very powerful tools that do object storage. But this kind of deployment is very similar to what companies like Zynga are using to run all of their games and Samsung is using to run their big platforms. They're looking to run large-scale infrastructure at a very low cost and deliver very reliable applications on it. But obviously, the pro here is it's inexpensive, it's reliable at scale, it's easy to build and easy to run. It's dark data center kind of architecture where if a server blows, you don't worry about it. If an entire rack goes out, you fix it on Thursday, not that second. But it's not a great platform to run that Exchange server because that Exchange server is not going to run all that well there. So what we're finding is that in the past, people wanted to build a cloud, they wanted to define one general architecture, And very often what they did was they tried to take the best of all these worlds. They would take, something that was interesting and cool about Amazon, maybe the model or the pricing or the APIs, maybe a concept like, SDN, and then they would take something from the traditional enterprise world like, VMware or really, very high performance networking and storage, and they would try to bring these together into a cloud that sort of offered people the next best, greatest thing. And we were guilty of this as anybody. But what we found is that it's very hard to do that, because when you end up building, something that combines both of these components, you very rarely develop a platform that is optimized for either of the big workload categories that actually exist in the environment. And so what we're seeing today is people who are deploying clouds for either traditional or distributed, or they're deploying single clouds that support both types of availability zones. So they'll deploy CloudStack, and they'll leverage CloudStack to run one availability zone that's configured very much like a vBlock or a vCenter or a FlexPod. It's enterprise-grade infrastructure. It may be running VMware. It's really optimized to run those traditional infrastructure environments. And then they'll deploy 3 or 4 more zones that are designed to run this next generation of application. And they'll start introducing it to their developers, and they'll start bringing it to the people who are thinking about the kind of applications they want to be running in the organization and the type of ISVs they want to purchase from. And so this is the future that we see people heading towards, which is clouds that are made up of really different types of infrastructure, developed for different types of workloads and optimized to run those workloads well. And this concept of availability zones really lends itself well to this concept, in the sense that not only are availability zones today sort of considered to be something that are distributed by geo, and CloudStack, most of our users and people that leverage CloudStack do this, but they're also things that can be defined by ownership. And we can have clouds that are made up of private zones and public zones. And now you're starting to see cloud zones that are, or availability zones that are defined by characteristics and type. And all of a sudden, this availability zone concept becomes really important. And people are deploying it in all sorts of different types of configurations and concepts, from shared availability zones between business partners, to privately owned availability zones that are part of a larger public cloud, to hosted availability zones that run in customers' data centers. In fact, if you stay for the next presentation, SoftLayer will be talking about running private clouds based on CloudStack for their customers that are really hosted availability zones that can be connected to and work with your cloud architecture and infrastructure. And companies like Redapt are building pre-built racks in a box that are effectively availability zones you can purchase and deploy very much like a Zynga or an Amazon-style architecture, and plug it into your data center. So you can leverage pre-built availability zones that are hosted. You can take availability zones that are built out of the box and plug them into your management architecture. You can even combine things like a Redapt-based cloud, which is an architecture that's very much scale out and very much optimized for the distributed workload, with FlexPods and vBlocks that are really optimized and sort of driven for those traditional applications. So combining these different kinds of zones and these different kinds of infrastructure resource pools, you're able to accomplish more and drive more different types of applications into this cloud infrastructure. So if I can just give you with a few concepts to take away from this, we're really still in very early days of what cloud computing is and what it's going to be. And while this may be the 4th Cloud Expo, I guarantee we'll be here in 5 to 10 years still talking about this. And some of these things aren't going to change. Effectively, legacy applications and traditional applications will always be part of the mix of what runs in your cloud architecture. So when you're thinking about the kind of cloud you want to build, make sure it can run both. Make sure you can run both that traditional enterprise application and these next generation architectures, because the vendors like SAP and Citrix and everyone who's your ISV partner are rewriting their applications to move from the traditional side to that distributed style as we speak. And you're going to see that more and more the vendors are going to be responsible for the availability of their own application, assuming you can give them some type of reliable infrastructure as a service. The thing that I will definitely say is, when you start your cloud project, whether it's picking a public vendor or a private vendor, start with applications, and then the very next step, consider how that application is going to be done reliably. Consider what all can fail in the application change and how you can handle that, how the platform you're using is designed to handle that failure, and make sure that it will handle it for your specific application. And don't just take well, we have a great DR story at its face. Run through that in detail for your application and the kind of applications you're going to be working on, because every application needs different things to be reliable. If you are a service provider and you're thinking about building a cloud or moving into the space and you're becoming a cloud provider, this same message holds. Consider that your customers are going to be bringing you multiple types of applications, and it's very difficult to build one cloud that will run all those applications very well. You need to consider different types of zones, different types of resource pools for the different types of applications that people bring. And then finally, make sure you choose platforms that are open, that are flexible, that give you the ability to continue to innovate and come up with new types of architecture and new types of zones, because there is a ton of exciting things happening here in the open source community where people are building new types of clouds and coming up with new types of reference architectures and leveraging this technology in ways that really haven't been done before. And I think there's a lot to be said for that. So anyways, thanks everyone for coming and listening so patiently and enjoying your food. I'm happy to take any questions if we have a couple.
Oh, and Jeff's right there. One for you, sir.
Hi, thanks, Shannon. But nice talk. I can't believe that you omitted to mention the Apache 4.0 CloudStack drop that happened today. This is the culmination of all this work to get it into Apache. So, talk that up, please.
Yes. That's a great point. I should have mentioned that today, the 4.0 release of CloudStack happened. The first Apache release since the incredibly hard work that the whole team has done to move CloudStack from a Citrix-owned product to effectively an open source Apache project. So it is an enormously exciting day for us and our team and for all of the people. I mean, it's been stunning how many people have jumped on board, have participated, have taken leadership positions. We've seen not only big companies like Cisco and NetApp and others get behind CloudStack, but also tons of individual developers, tons of people from the Apache world, tons of people from some of the other Apache projects like Hadoop and Tomcat, and joining up and participating. So it's been an amazing 5-6 months since we made the decision to donate CloudStack to Apache, and today is very much the culmination of all of that. So thank you.
And one criticism. You repeated the old story that the first workload for AWS was Amazon Retail, which of course was not the case, right? Amazon Retail was the reason for AWS was A, build a service, and B, test that service out and then provide a target for re-architecting Amazon Retail. So we never, I was at Amazon at the time, we never intended to run the old Amazon code on anything like AWS. Build the cloud first, then adapt the application, which is, plays into the two models that you were talking about earlier.
That's a great point, because it's one to easily. I think the point I was trying to make, and maybe should have made better, is that because of running the Amazon application for years ahead of time, the institutional knowledge of how to then redo this and how to build a platform that would run the new version of Amazon is the part that I think maybe drove the success of Amazon. So many people who actually ran it.
More about the negative lessons.
Probably. That makes a lot of sense, the things that have done wrong.
When you talked about the different groups of the service providers, the web guys, the IT organizations, gave lots of examples like Disney. Who wasn't in there was any of the SaaS vendors. I mean, no example is NetSuite or Salesforce or the smaller ones. Is there a reason for that? Are there different considerations for ISVs? It seems like the same issues for people moving to SaaS as your other categories, but I would expect some names of some SaaS
Yeah,
vendors.
not at all. No, I don't think there's any real reason. One of the interesting things with SaaS is a lot of the biggest SaaS vendors and companies that have been in this space for some time started with effectively building their underlying infrastructure to deliver this from the ground up. And so in a lot of ways, SaaS predates IaaS. And so a lot of the conversations we've had with SaaS vendors, even including our own SaaS organization, like the GoToMeeting side, where Citrix is the, I think, 5th biggest SaaS vendor in the world. And we have things like ShareFile and GoToMeeting that are really big SaaS applications. But a lot of these, in the same as Amazon, in a sense, are running today on a lot of bare metal infrastructure. They've been in place for some time. And right now, a lot of them are going through sort of that next generation architectural reviews. And they're looking at how cloud platforms can power SaaS services. But there are a number of SaaS companies we do work with, but it's... Exactly. And there really is a lot of SaaS development going on this type of platform as well. It's a good question.
Over here.
How do you see high-performance visualization playing into the moving of traditional applications onto the cloud?
I'm sorry, can you just repeat the question one more time?
How do you see high-performance visualization helping move traditional applications onto the cloud?
Yeah, that's a good question. I think when we talk to customers who are sort of looking at the next generation of virtualization and what they're going to be, what they're going to use to build their clouds over the next few years, I find that there's still, most of the conversation today is about keeping things the same, and that people want to take what exists and onboard it, as opposed to necessarily re-architecting the existing systems and using that to become the way they bring their applications on board. So, for instance, we go into a lot of enterprises that have sort of wall-to-wall VMware infrastructure. They've been using it for years. It's what they use to run their applications. And as they think about sort of the next generation of their architecture, it's not a we're getting rid of VMware and we're moving away from it. To the contrary, it's VMware is excellent for running these types of workloads, but they're looking at ways to run workloads in a different way as well. So they want to offer both and run both types of infrastructure. But I don't know if that answers your question well, but it seems to me that it's by no means a situation where people are moving away from technologies that are proven that work in their environment. It's much more about looking at new ways to innovate and deliver services less expensively, more efficiently, more reliably for a lower cost, and optimizing in that direction.
I'm looking for hands, but I'm not seeing them, so I am prepared to say that we're going to round off what Shannon Williams calls the best keynote gig in the industry, the Lunchtime Focus Keynote. Let us say thank you to Shannon and to Citrix for lunch.
Thank you.
We have soft